morning. Once again, I welcome you all to this lecture, Foundation Engineering, and we are discussing on earth pressure theories. And in fact, our main objective is to do stability analysis of the earth retaining wall. And as I have mentioned you before that the main component in earth stability analysis of the retaining wall is the earth pressure calculation. There are other loading, but earth pressure is one of the most important component, and first of all you need to know how to calculate the earth pressure and where they act. And for that I have already discussed Wedge method, Rankine's theory, Coulomb's theory, and now most of the cases what I have discussed here so far, it is for questionless soil, and that means backfill material is sand mostly, and but sometime pure sand may not be the situation most of the cases. So, you may have to use sometime C5 soil also, and if you use C5 soil, then how to calculate earth pressure behind the wall under different condition like active and passive case. So, we will see that first, and then subsequently we will see some other applications. So, let me see that this is a case of active earth pressure, and we know already we have we know that this is the wall and this is wall, and in fact, let me. So, this is actually behind the wall and this is the backfill and C5 soil. As usual, I can find out sigma 1 by normal procedure. Sigma 1 is nothing but gamma multiplied by h, and then I have to find out sigma 3, which is nothing but here lateral pressure or earth pressure. And so, if the soil is C5, then if you plot in a tau versus sigma or S or tau, you can S also you can think of tau actually, tau versus sigma or shear strength versus sigma if you plot, and then generally you will have the envelope, it will be intersect at tau axis, and if you extend it will meet somewhere here. Now, that means this is the failure envelope, this is the failure envelope, and if full active case develop in this case, then corresponding to that there will be a more envelope, more circle, and that should this may be the more circle for that condition. So, that means this is originally sigma 1, and with the movement of the wall away from the backfill, sigma 1 was decreasing. Suppose somewhere here or then somewhere here like that. Finally, at exactly at fully active condition sigma 3, sigma 1 reduces to this value. Suppose this is sigma 3. So, this sigma 3 is nothing but the lateral earth pressure in the wall in active condition. So, this circle will be tangential to this. Now, if I use this failure envelope and this more circle, and then from these actually if I write this tau, this also has to be written as tau. So, if I use this geometrically, and you can see that this is the center of the circle, and then if I join that here at where it is tangent. So, that become the radius, and then this radius will be actually this is sigma 1 minus sigma 3 by 2 definitely, and again we can find out this distance as sigma 1 plus sigma 3 by 2, this distance, and of course, C this one if I consider this as a C, this portion as C and this is phi. So, this distance will be C cot phi. Now, using this geometry and we can consider this this triangle. Suppose this is O, A and B. This triangle I have if I take and if I express sin phi, then sin phi will be this divided by this. So, that is the thing I will try to do in the next slide. you can see here that we have expressed sin phi, and that is radius by this hypotenuse actually here. And if you see that this is the radius and this is the, that means if I draw the diagram, it was something like that and it was something like this. So, this is radius and this is this distance was sigma 1 plus sigma 1 plus sigma 3 by 2, and this was c cot phi. So, that is why. So, this our sin phi is, this is phi, sin phi is this divided by this. So, if I do that, then sigma 1 minus sigma 3 by 2, sigma 1 plus sigma 3 by 2 plus c cot phi, and if you simplify further it become like this. So, sigma 1 minus sigma 3 by sigma 1 plus sigma 3 plus c 2 c cot phi. And now, if I substitute then and if we express sigma 3, because our I know sigma 1, because sigma 1 is nothing but gamma times h, and I need to find out sigma 3, and that means I want to express sigma 3 in terms of sigma 1, c and other parameters like k, kp, whatever maybe. So, if I simplify this one and express sigma 3, then it will become in this form. So, in this for sigma 3 will be sigma 1 minus sin phi by 1 plus phi minus 2 c under root 1 minus sin phi by 1 plus sin phi, and you can see this is nothing but we know k a already we have done, and this is actually nothing but root k a. So, I can write that sigma 3 will be equal to sigma 1 k a minus 2 c root k a. That means, at any depth, suppose this is the wall and it contains C phi soil here, then if I want to find out the pressure at any depth, then what I have to do? I have to find out gamma times A sigma 1 multiplied by k, that is normal one, and it has to be reduced because of this cohesion part, that how it will be reduced? 2 c times under root k a. So, you can, and if it is suppose if I want to find out the surface, that means when your normal stress, that means sigma 1 is 0, then you can see still there is a value minus 2 c root k a. So, that means at the surface there will be minus value, there will be a minus value which will be equal to minus 2 c root k a. So, this will be there at the surface, and when you go deeper and deeper, this minus value will be reduced, because when h is some small value. So, it will be plus and this is minus. So, it will be reduced, and at some depth it will become 0, and then finally, when it become, you further increase the depth, then it will become a positive value like this. So, that means for this case, when soil the wall retained wall retained C phi backfill, then in that case your earth pressure diagram will be like this, this portion will be negative and this portion will be positive. So, that means of course, this will give you thrust in this direction and this will give you tension. So, that I will discuss later on what is the effect of it. So, for the time being, what I want to mention here actually to make clear that if the backfill retains C phi soil, how to find out lateral pressure. That means, this is sigma 3 is nothing but I can say here sigma active, okay, sigma 3 here sigma active, and your this will be in terms of sigma 1 k a, that means sigma 1 is nothing but gamma times h. Of course, if it is a water table is there, gamma submerged times h minus 2 c root k. So, this is the way one can find out the lateral earth pressure for C phi soil. Similarly, if I take a passive case, so it will be similar actually. In fact, it will be reverse of active case, that means, if the wall is somewhere here and retaining C phi soil, the wall moves in this direction. When wall moves this direction, then initially there will be somewhere at depth there will be some sigma. So, that should be actually in terms of our understanding, this must be sigma 1, because that is known vertical stress, and this will be slowly when wall moves this direction, this value will increase and finally reach to a maximum value before failure. So, that suppose this is the one, that must be suppose sigma 3, because that is the one, though magnitude wise this is sigma 1, that is larger, but I am here sigma 3, that means which is unknown. Initially sigma 1 as applied, it is there, and then with the movement of the wall, pressure is increasing and is becoming sigma 3, and that sigma 3 actually is the nothing but sigma passive. Okay, sigma passive. The earlier case was sigma active and sigma passive. So, now this will be a Mohr circle, and if I draw this Mohr circle, it will be tangential to the envelope of the failure envelope of the soil, and I know that this is the failure envelope, and this is generally when C phi soil, the failure envelope will be intersecting, this is support tau axis, it will be intersect at a C, where this must be the value of C, and then if I extend this line, this is the failure envelope, if we extend, it will intersect the x axis somewhere here, that means sigma axis somewhere here, and that distance if it is phi, then I can find out from the geometry C cot phi. So, again similar to that, if I do it here, then you can see here that sigma 3 here actually bigger, sigma 3 for this case is big. So, bigger value. So, sigma 3 minus sigma 1, similar to that if I take this triangle and then sin phi will be this divided by this, and if I do that and simplify, then this will get this equation. And once you get this equation, then you can further simplify to find out sigma 3, because which is unknown to us. So, sigma 3 here I have expressed, and sigma 3 here actually nothing but sigma p, passive pressure. Okay. And this will be once when you expressed what in terms of what I should express? I should express in terms of sigma 1, which is known, which is equal to gamma times h, and if it is water table is there, it is gamma submerged times h, and this become 1 plus sin phi by 1 minus sin phi plus 2 c multiplied by under root 1 plus sin phi by 1 minus sin phi. Now, you can see this is nothing but K p, and this one nothing but under root K p. So, this one again further simplification I can do, and I can write this sigma 3 equal to sigma 1 K p plus 2 c root K p, or I can write gamma h K p plus 2 c root K p. So, when there is a C phi soil, the pressure diagram, pressure expression sigma p will be a lateral earth pressure, lateral passive pressure is can be expressed like this. So, that means, if I height is 0, that means at the surface, that at this surface of the top surface of the wall, I want to find out the pressure. You can see this part becomes 0, but still there is a positive part. So, that means, when C phi soil passive case, it will start with a positive value, and then if h increases, then this will be further increase the positive value. That means, your pressure diagram will be like this. Whereas, where you have seen that when it is an active case, at the surface there is a negative value, and then it will increase further and it become a positive value. But for passive case, it is throughout positive, with at the top surface some value and at the bottom surface some other value with higher magnitude. So, this is actually for earth pressure diagram procedure for calculating active pressure and passive pressure for your C phi soil, when the backfill retained C phi soil. So, two important expression you have to remember, that is actually I will just go to the next slide and I will show you. you can see that as I have shown before, that if this is the wall and at height actually this is sigma 1 and this is sigma 3, and then if I write sigma 1 or I can say sigma 3 as sigma 3, when it is active it become gamma h k a minus 2 c root k a, and when it is passive, that means sigma 3 will be equal to gamma h k p plus 2 c root k p. So, if I keep side by side, this is the difference I can see, you can see here, and this is nothing but sigma active and this is nothing but sigma passive. So, now with the variation of h depth, if I want to draw the pressure distribution, earth pressure distribution over depth, then for the active case you can see, as I have mentioned, that when h becomes 0, then I will get this whole portion will be the whole part of the 0 and only value will be minus 2 c root k. So, that is actually at the surface we will get a value, negative value 2 c root k a, and when h increases then this minus plus. So, it will be negative value will be decreasing, and at some time when negative value and positive value are equal, then it becomes 0, and when further increase of h, it will give you a value at the bottom of the wall, something like that gamma h root k a, gamma h k a minus 2 c root k a. So, this is the actually earth pressure distribution, active earth pressure distribution for C5 soil behind the wall. Similarly, if there is a passive case, then you can see here that when you put h equal to 0, then entire thing will be 0. That means, your value will be at the surface will be 2 c root k p, and when you increase h, then from here this will be constant throughout the depth, suppose, and then assuming this part is missing, this part is missing, this is a constant part, only with the increase of h this value will be increasing linearly. So, this part will be there. So, that means, you have this part 2 c root k p, and this part will be gamma h k p, and these two together will have the earth pressure at the bottom. So, now if this is the situation, you know the pressure distribution, then if you want to find out the thrust, then what I will do? I will find out the area of this diagram. So, this area I can divide into two parts. For this rectangular part I will do suppose this P 1, and for triangular part I can say P 2, and then P will be equal to P 1 plus P 2. So, total thrust will be equal to P 1 plus P 2. So, like that I can calculate. Similarly, you can find out the point of application of the earth pressure. How to find out? For P 1 I can find out what is the H 1, for P 2 also I can find out what is the H 1, this is suppose P 2. So, this is H 1. So, finally, I can take and P p, suppose this is acting and this is height actually suppose y bar. Then what I can do? P p multiplied by y bar will be equal to P 1 into H 1 plus P 2 into H 2. So, this way, so everything is known, P 1 H 1, P 2 H 2, P p, everything is known, only unknown is y. So, I can find out from this equation. So, that way actually one can find out the total thrust, then point of application of the. Similarly, for this case, generally negative part we ignore, we find out the area of this diagram, and this will be acting at 1/3 height from the base of the triangle. So, that is the way one can find out. Next one is, as I have mentioned, that when the retaining wall retains a backfill with C5, then we have seen that at the surface we are getting negative pressure, but negative pressure soil cannot take. As a result, this is nothing but tension, and because of that tension there will be crack will form, and you can see this is the thing I can visualize that because of C5 soil, it crack will form and it will go up to some depth, up to what depth this crack will go, that means where actually pressure will become 0 you can find out, and that means when you excavate generally we need to give support, but when it is sheep-high soil because of this if you excavate this pressure is getting released. So, because of that there is no need to put support actually up to some depth actually up to certain depth we can excavate the sheep-high soil without any support. So, if you want to find out up to what depth you can excavate without support, that is the thing I can this analysis can be utilized. So, you can see here that first of all I can find out at what depth your tension becomes 0. So, I know that your formula is our formula is sigma active will be equal to gamma h k a minus 2 c root k a. This is the expression. So, if I say that sigma become 0. So, if I equate this to 0, then from here I will get a value of h. From here actually if I equate to 0, then I will get h equal to 2 c this is the one h actually 2 c root k a divided by gamma k a. So, that means it will be 2 c by gamma root k a. So, that means at what depth, that means I have set I assume that at a depth h your pressure or tension becomes 0, that means this is the one. So, this is the one h. So, and I have expressed the general expression for sigma or lateral pressure this, and I equate this one to 0 because that I have assumed that h depth that becomes 0. So, if I equate to this expression 0, then from simplifying I get h equal to 2 c by gamma root k. That means, up to this depth actually tension crack will go, but since this is a pressure released because of excavation, that means equal to this double the amount if I cut also without support it can stand. So, that is why so depth of unsupported cut will be just twice of that. So, this is actually depth of tension crack. So, if I release this one, so that means this minus and plus this resultant becomes 0. So, because of that, though we could find out that depth at which the pressure is becoming 0 is the 2 c by root k a, but depth up to which we can cut without support will be twice that depth. Why it is so? Because this minus diagram and this plus diagram, if I go h here, so this diagram and this diagram will be identical, and then this will be with the increase of h from here it is negatively increasing, and with the increase of h it is positively decreases this way. So, this diagram and this diagram will be equal. So, because of that, so the resultant, so this is minus and this is plus. So, because of that resultant pressure will be 0, and that means up to that if we cut, that means wall is not giving any backfill is not giving any pressure on the wall. So, that means up to this depth we can excavate without any support. So, that means HC is the critical depth, and H cut or excavation without support will be that way twice if I do, that means it will be 4 c by gamma root k a. Okay. So, this one I will show you in details in the next slide again, and you can see here. So, that is the thing I have done here. You can see that our general expression for sigma 3 equal to sigma 1 gamma k a minus 2 c root k a. This is the formula. At ground surface h equal to 0 and sigma 3 become minus 2 a, that is tension, that already I have mentioned, and the theoretical depth of the crack h t, theoretical depth at which that tension crack will reach, that I suppose give a different name h t, can be determined by recognizing that at the bottom of the crack sigma 3 will be 0. That means that this is the wall and this is the ground surface, and crack something like this it comes. So, this is the depth of tension crack. So, h t if I say, so that h t that means at this depth, that means sigma 3 will be 0. So, this 0 to be equal to gamma h t k a minus 2 c root k a I do, then from here I can get h t equal to 2 c by gamma root k a. So, depth of excavation should be depth of excavation, that means h excavation will be without support will be twice of h t. So, that means equal to 4 c by gamma root k a. Okay. So, this is the way one can find out. So, these are useful for some earth pressure calculation, also later on we will show the use of it. Next part is that in addition to this, sometime there may be some surcharge, there may be some surcharge pressure. This is the ground surface, you can see this is the ground surface, and on that ground surface additionally if there is a pressure. How we can visualize this one? During excavation or some construction work, there may be some loading truck or there may be excavation equipment or something else is there. In that case, we can visualize there is some amount of distributed load acting on that surface. If it is there, then how to consider that? So, that actually, so this is sigma 1 because of this loading, and this is sigma 3 is the lateral pressure. Sigma 1 actually we can visualize as sigma 1 as gamma h plus q, and then sigma 3 can be visualized as sigma 3 is a gamma h instead of gamma h k a, instead of gamma h k a, this is nothing but k a, and this is nothing but root k a, this is k a and this is root k a. So, gamma h k a minus 2 c root k a, 2 c root k a, this is the one we can visualize, but when there is a surcharge I can visualize as gamma h plus q k a minus 2 c root k a. So, that means I can, what way it is different, that means one additional term. So, sigma 3 was this gamma h k a minus 2 c root k a. Now, if I simplify this one, it is becoming k a multiplied by q plus gamma h k a minus 2 c root k a. So, that means this part was there already. Now, because of this q, this is additional part is coming, and that is actually throughout the depth, it is independent of depth. So, if I draw the pressure diagram, so that means if I draw the pressure diagram for C5 soil, and then additionally if I give the q times k a another constant throughout the depth, then that is the total pressure diagram for the surcharge case. So, this can be seen in the next slide. Let me see. You can see that suppose that was the surcharge was there. I will draw that one again. Suppose this is the wall and this is there is a surcharge, and suppose this is a suppose cohesionless soil I will take first. So, cohesionless soil, if it is a cohesionless soil, then pressure diagram will be something like this, okay, gamma h k a. So, it will be gamma h k a, is it not? And in addition to that, I can find out the effect of surcharge. What I will do effect of surcharge? I will do this diagram, this will be equal to this value will be equal to throughout everywhere it will be k a times q a. So, now if I want to find out the thrust, then what will happen? So, this triangular diagram, this will be suppose P 1 acting somewhere here, and this is suppose P 2 acting somewhere here, P 1 and this is P 1 and this is P 2. So, P will be equal to P 1 plus P 2, and resultant actually I can find out y bar multiplied by P equal to P 1 H 1 plus P 2 H 2 H 2. So, P 1 H 1 means this is H 1 and this is suppose H 2 So, and y bar actually, suppose if the resultant thrust somewhere here, this is the one resultant thrust actually somewhere actually this is the resultant thrust. So, that become y bar, suppose if I consider. So, that way actually we can find out the thrust. So, that what is the thing actually now to note, if it is a surcharge, then only this is the additional q times K, and this is the one I have considered as a cohesionless soil. If instead of cohesionless soil, if it is C phi soil, then corresponding diagram I would have drawn. In addition, I could have drawn this. So, that means, so first of all, without surcharge you draw the pressure diagram and then add another diagram which will be throughout the depth pressure intensity constant, which is equal to K times Q, which will be equal to like this, and then sum it, then we can find out the resultant pressure and resultant thrust and resultant all those things. Okay. With this, actually almost earth pressure theories I have whatever relevant I have just completed, and now I will try to show the calculation, that means earth pressure calculation through some application and then stability analysis. Okay. Thank you.